Let's look at one more application of quadratic equations in real life situations. Okay, so here's the situation here. I've always had the dream to fly like a bird. The best way that I can do that is to hop into a catapult and have someone fire me across, and I'll fly for a few seconds and I will achieve my dream. So let's take a look at what that's going to look like. Right, if I'm reading this situation, it says that the catapult is 3 feet off the ground. So let's draw some ground. Okay, and I'm a little bit above the ground. Right, here's the catapult. Okay, I'll draw myself. I'm not on the ground. Okay, I'm a little bit above the ground inside the catapult, and I'm going to fire up in the air, and I'm going to come back down, and I'm going to hit the ground. Okay, so I'm a little bit above the ground, and I come back, and when I'm on the ground when I get to the other side. Okay, hopefully safely. Okay, so they're telling me some information about this. The first thing is that I am 3 feet off the ground. That's really important. The second is the moment I leave the catapult at that exact instance, I am traveling at 20 feet per second. Okay, so I gave you an equation in the last video that says anytime we drop something or anytime we throw something, this is called projectile motion, right? Anytime we do either of these two things, we can model it with this equation, assuming we're in feet per second, of h equals negative 16t squared plus vt plus s. Okay, v represented velocity and t represented how much time. V represented velocity and s represented our starting height, and those are the two things that they gave us. So I'm going to write my equation and I'm going to fill in that information. So I'm going to go to mine and I'm going to say h equals negative 16t squared plus 20t plus 3. Right? So I plugged in a velocity of 20 and a starting height of 3 feet off the ground. This is the equation that I'm going to use to answer the questions that are below. Right, so this is anytime an object is thrown, or anytime an object is swung, or anytime an object is dropped. Right, we can use this equation. Okay, so let's answer the first question. How long is it going to take for me to fly through the air, get to the other side of my flight, and hit the ground? So what I'm really wondering is, taking a look at my picture, is when am I going to be right here? Okay, so it looks like I need to fill in some information. They're asking me how long, which means they're saying we don't know what t is. That's what they're asking us to find, which means we need to figure out what is the height. In order for us to solve for t, we need to know what the height is. Well, in this case, they're talking about hitting the ground, which is at a height of 0 feet. Right? That's where the ground is. So I'm going to plug in a 0 anytime they tell me that I'm on the ground, because that's how high I am. Okay? And if you take a look, this is really just another quadratic formula problem. Okay? It's already set equal to 0 because we were at 0 feet. So we're going to pull up our calculator. Okay, and see what the answer comes out to be. So this looks like negative 20 plus or minus. Let's go do b squared minus 4ac on the calculator itself. Right, so it's going to be, in our case, 20 squared minus 4 times negative 16 times 3. Oh, got to close the parentheses. Times 3. Okay, so there's b squared minus 4ac, which means underneath my radical I want 592. Okay. And it's all over 2a. Well, a for us is negative 16, so 2 times negative 16 will be negative 32. Okay, so my t, my time, is equal to this setup, right? Which I need to simplify. I want to answer their questions, which means I want to tell them approximately how many seconds, right? So I'm going to say, in this case, let's simplify the numerator with the plus sign, and then we'll do it again with the minus sign. So negative 20 plus the square root of 592. Okay. Hit enter and get your answer. You want to simplify your numerator and then use that to divide that by your denominator. So there's my numerator with the plus sign. Divide it by negative 32. Okay, and it's going to tell me negative 0.14 seconds. So let's write that down. Okay, t equals negative 0.14 seconds. Okay, so let's try the other one. Okay, we need to get two answers from this. So I'm going to say, in this case, negative 20 minus square root of 592. Okay. And I'm going to hit enter again, simplify my numerator, and then divide that by negative 32. That's what's on the bottom of my fraction. And it comes out to be 1.39 seconds. Okay, so let's write that one down. T equals 1.39. Okay, so if I'm taking a look and I'm trying to answer their question, one of these doesn't make any sense. In this case, I can't have a negative amount of time, so I'm going to throw this one out and say negative any seconds doesn't make any sense. So I'm going to say 1.39 seconds. That's the answer to their question. It took me 1.39 seconds to get launched out of the catapult, go all the way to the top, come all the way back down, and hit the ground again. Okay, we've answered their first question. So let's take a look at the second one. It's saying, when am I going to be? Again, so let's take a look. When is a key word. when, how much time has passed. That's what when is saying. How much time has passed for me to be at the highest point of my flight. So let's take a look at our picture again. They're saying I'm traveling along my flight, I get to the highest point. Okay, that's right here. This is the highest point. We have a word for that highest point where I stop going up and turn around and start coming back down, and we call that the vertex. So what I'm really asking is, what is the vertex of this equation that I gave you, right? This one that we wrote here, what's the vertex, right? So in our problem, we replaced x with t, and we replaced y with h, right? So usually we have a vertex that looks like this, but I'm not using x and y in this equation. I replaced all my x's with t's, and I replaced all my y's with h's. So I'm really saying when we find the first part of the vertex, you're finding the time, and when we plug that time back in, we're going to find out how high I am. So when we're answering the question when, it's really going to be t is equal to negative b over 2a. That's the first part of the vertex. That's how we found it when we were graphing. We're going to do the same thing here. Okay, so I'm going to go and I'm going to plug in. Negative b for us was negative 20. Okay, and my a value is negative 16, so 2 times negative 16. Okay, so again, we can go to the calculator and have it do that for us. Okay, we're going to say, in this case, negative 20 divided by negative 32 is what would be on the bottom when I do 2 times 16. Okay, and that's going to be 0.625. That is the number of seconds that have passed for me to get as high as I'm going to go. 0.625 seconds. Okay, so I'm traveling. It took me 0.625 seconds to get up here, and then I need to continue back down my path. I've answered the question. When am I going to be at my highest point? I'm going to be there at 0.625 seconds. So a little bit more than a half a second for me to get as high as I'm going to go on my path. Okay. The second question is, what was the maximum height of my journey? So I'm flying up in this catapult. Eventually I get as high as I'm going to go, and we know that that took 0.625 seconds. And then I turn around and I start falling back to the earth, and I hit the ground. Right. So they're saying, when am I, or what is that maximum height? So if you think about, again, this vertex problem, I'm kind of saying I know for my vertex problem that t is 0.625, and I want to know the h part of the vertex. Well, when we were doing this with x and y, what we did was we took the x that came out of negative b over 2a, and we went back and we plugged it in and find out what h was. Well, we're going to do the same thing. I'm going to say 0.625. Let's plug it in and find out what comes out for h. H is equal to negative 16t squared. Okay? But in this case, instead of t, we're going to replace t with an amount of time that we know, right? In this case, we're going to replace t with 0.625, right? So let's fill that in. Okay? We know time in this case, okay? Plus 20 times that same 0.625 plus 3, okay? So again, that's the hard part, is writing that out. We just got to go to our calculator and have it tell us what the number is. So in this case, negative 16, okay, times 0.625, okay, squared plus 20 times 0.625, okay, plus 3. Okay. We're going to enter, and it's going to tell us 9.25. So they're saying h, when I plugged in 0.625, is 9.25. My units up here for height were feet, so it's number of feet that I traveled. So this wasn't a very epic journey. It looks like I was only on my entire journey for about 1.4 seconds. I was as high as I was going to go after about a half of a second, a little bit more than a half a second, 0.625, and I only ever got about 9.25 feet off the ground, which is not very far at all. Right? But we were able to answer all their questions. We started off with the general projectile motion formula. We plugged in the information that they told us, which in this case was that the velocity was 20 and the height was 3. And then I answered their questions. They wanted to know about time at 0 feet, which is what hitting the ground is, right? And that was 1.4 seconds. Okay, it took me 0.625 seconds to get it to my vertex. Okay, and I was 9.25 feet when I got at 0.625 seconds, which was at the top of my flight.